Gets annoying. Okay, so hello, welcome to the Centre for Alternative Technology. So this centre's been here since 1974. We just had our 40th anniversary. So this location was picked by, so in the 70s, there were a lot of concerns and worries about energy. So for example, in the 70s in the Western world, so in the US and in Europe, a lot of the oil production peaked. So there was already concerns about energy security. As well as that, there was an oil embargo, so it was very difficult sometimes to get energy, and the costs were really, really high at some points. And a lot of people were really concerned about this and wanted to try and investigate different ways of generating energy for security, but also for environmental reasons as well. And so a lot of there was a mixture of idealists and kind of hippies and engineers decided to come and live off the grid, so off the national electricity system, and generate their own electricity. And they came here, which is the middle of nowhere, which is really difficult to get to in Wales, where it rains all the time and it's very cold and it snows. They came here basically because this area was free. It was given to them by some quite wealthy people who were also concerned about energy. It used to be a slate quarry. Do you know what slate is? Slate is this material.
These rocks here,
yeah?
Yeah,
Just
yeah.
this material.
Slate jest specjalny rodzaj slajdu, wszędzie to w Walii występuje. To są te skały, te wszystkie góry.
Tak.
To jest po polsku łupek, jakiś rodzaj łupka.
Budują z tego wciąż chyba, tak? Domy, dachy.
Domy to budują te dachówki takie brązowe jak wszędzie, to jak to widzicie.
So it's just one called Venus, right? Yeah.
To nazywa slate.
Yeah, so it's quite internationally, it's quite famous for roof material. So yeah, it's good for roofs, like you can see over here. So for 200 years, this site, which we're going to see later on, maybe this afternoon, there was a quarry where they dug the slate out of the ground, and then they would ship it around the world. So there's houses all over the world that have slate from this quarry. But in 1951, they decided to close the quarry, and it was just empty for 30 years. But there's the problem with slate, when you dig slate out of the ground, is that it has different properties. So sometimes it has a lot of metal or a lot of iron in it, or a lot of copper, and then when it rains, if it has iron, it turns red, and if it has copper, then it turns green, and people didn't like that. They just want the blue slate. So the slate that they couldn't use, they threw over the side of the quarry, and it made a really big pile of slate, and that's what we're standing on now. We're just standing on a really big pile of waste slate. So you can see, if you look down here, this isn't a natural hill, this isn't a natural this is just an artificial hill. The waste is another kind of pure, because people just want that blue colour. Yeah.
No, panowie rozumiecie to coś? Czy trzeba wam tłumaczyć? Rozumiemy? No to dobra. Are you sure?
Okay, tell me if I'm speaking too fast. But, it's fine, okay, cool. So we do sometimes get structural engineers to come and check it's okay and it's safe, and it is safe, it's okay. And they, so the people who came here, they planted a lot of trees to try and, so because the roots of the trees, they hold the slate in place. But when they got here, this is what they arrived to. So this is what it was like. So this is 1974.
Oh my god. Tak to wyglądało.
So these lines, this is where they had a truck, and they would drive along and put the slate over the side. So they've made these lines. So when the people who came here in 1974, when they arrived, they didn't want to use any energy. They wanted to do everything by hand or by renewable energy. So a lot of the things that you see here, they built by hand. You know, like to move these rocks, to move everything, it was all by hand.
They didn't use any vehicles or machines?
No, they used like horses and things. It was all like without. It was kind of crazy. That's why some of the stuff here, it's like really handmade. But since then, now we have connection to the grid. But so do these guys? Do they not? They're happy there.
Panowie,
Tomek, jaki czujesz?
skupić się, co pani mówi.
Cudownie wręcz.
So when they arrived, so this was back in the 70s. They made this prediction that energy use was going to keep increasing till it was at a point where it was unsustainable and not manageable. And they proposed that instead of using more energy and trying to find more energy, that we just use less energy. And they wanted to make it so that when we got to 2025, we'd be using even less energy than in the 70s. And people came here and they stayed here 5 years and they tried out lots of different technologies. So they tried out wind turbines, they tried out hydro turbines, and then they made this plan and they gave this to the government. And they thought the government would say, "Okay, we'll do that," but the government didn't do it. So then they
They
stayed
only
here.
promised.
Yeah.
Well,
Yeah, well, they gave this kind of, but yeah, that's apparently what happened. So then, the centre didn't close and it stayed. But when the beginning, it was just a community of people that were trying to find these solutions. But then lots of people from the outside, they kept coming and saying, "Can you teach me about solar panels, or can you teach me about organic food or something?" Because of that, they decided that they would open as a centre and let people come and then run courses and things. And then that kind of evolved, and now so about maybe more than 5 years ago, maybe 10 years ago, we started running master's courses, so university level courses. So we have one course called Renewable Energy for the Built Environment, so that's an MSc, and then another one for sustainable architecture. So we also run installers courses for people who are installing solar panels or biomass boilers and things like that.
Were you doing the course exactly here in this place?
Yeah. So this is like kind of like a university a bit, but people come for 1 week every month, and they do this really intense week, and they do that for a year or 2 years. Then they complete the masters like that. So it's not going every day to university. It's just one really intense week where you do like 8-9 hour days of lectures for 7 days or something.
And the cost for the course is?
It's the same as if you would do it in a normal university. It's like, I think it's like 7,000 or something, like
Right.
£7,000, something like that. Yeah. So if anyone's interested in that for later on, yeah. Yeah.
Pana życie po szkole było.
Nie mam 7
Right.
7
tysięcy.
Is it really expensive? How much is a master's in Poland? Is it really?
We don't pay
It's
actually
free.
for that,
For
yes,
masters?
yes.
Wow, okay, cool. Yeah,
In Poland
that's
it's
better. Yeah. That's really cool.
It's strange.
Yeah.
People finish studying in Poland and come here to work.
Yeah, I can imagine. Yeah. Okay, so we have a number of technologies that kind of illustrate using energy less. So this system here, this is the Cliff Railway. So this is the train. So we use this because, as I was saying, people started to come here because they wanted to learn about alternative energy. But it's really difficult to get up if you walked upstairs. Yeah, and it's really steep. So it had no disabled access, and no access to kind of anybody who had any problem walking up the hill. So in 1992, they decided to open this railway. So this doesn't use any electricity. Well, it uses a tiny amount of electricity for the computer systems. But apart from that, it's called a water balanced railway. So did you all see there's a kind of small lake out there?
Yeah.
And we use that as kind of like a battery. So we let the water run into the lake, we store it there, and then when we need to move people up and down the hill, so people get in at the bottom, and then we press the button at the top that says start filling. This railway, it takes water from that lake, fills the tank in the bottom of the train, and then when that train is heavier than that one, we release the brakes.
It's water
And then
power.
it's water powered, yeah, it's gravity, it uses gravity.
Widzicie?
Rozumiecie jak to?
Słyszycie?
Żeby ta kolejka działała, to woda z jeziora
Podciągane
jest.
wody się napełnia i wciąga.
Zaczyna przeważać
Lucky
ciężkość i ciągnie w dół.
Yeah, a
a
lot of
potem-
rain.
Wales,
Yeah,
Wales
yeah.
good for it.
Yeah, we're really known for rain, yeah. But we have a reservoir, we have a private reservoir, which we're going to see later because we're doing a hydroelectric practice.
Does it this many times a day? Yeah.
Yeah,
So
yeah.
it is enough water.
Well, so every morning, usually I go up to the reservoir at the top, and we see how much water we've got, and then we judge how long we can run it for. So sometimes maybe we only run it for half a day, or we only run it for people who are disabled, or whatever, or we only run full carriages. But in the winter it's
There
okay.
is no help from any other energy. Only this one.
For this system.
Yeah.
But yeah, well, we're just a tiny bit of electricity for the signals to be sent between the two stations. But apart from that, yeah, it's just when they get to the bottom, they're opened by there's a hydraulic ram at the bottom, and that opens the bottom of the tank, and the water just runs into the river. So we just divert the water, so it rains onto the lake, direct it into this, and then let it out of the bottom. So we're not generating any energy at this point. We're just using it to make the most of gravity. So yeah, there's a lot of I don't know, because there are some of these in the UK. They used to be very popular in Victorian times, but then they swapped them for electricity when electricity was very cheap. And now electricity is really expensive again, so people want to convert back to this system. But you have to have a lot of water available to you, which we have. We have a lot of water, and we have a private reservoir because the people who worked in the quarry before, they used water power as a cutting tool. So they fed the water to a wheel that allowed them to do some cutting. So from then on, really, when the people arrived here, they really felt a lot. They felt very strongly about energy crisis, and they really cared about reducing the amount of energy we used and finding new ways to generate it. But since then we know we don't just have an energy problem. We have a problem in that we're living on a planet with finite resources. Fresh water, land for growing things. All of these things are restricted, and we're trying to live in a way that suggests that they're not restricted. So we look at a lot of things here now. We look at water use, we look at food, we look at land, we look at transport. Just ways to live in a way that reflects the resources that we have, and doesn't mean that we're just using everything really quickly and then leaving ourselves in a really difficult situation. But that's difficult because it requires a lot of change. So usually when we do this tour, we get people to look. Now, if you look at this landscape, do you feel like this is a natural landscape? This is a natural view.
Yeah.
So what do we have here? We've got some trees, we've got grass and things like that. So on the other side of the road, that's the national park. That's called the Snowdonia. That's a mountain there. I don't know what it's called. But that's a national park. That's like a protected area. But these trees, these aren't natural trees. These aren't even British trees. This is conifer. This is a conifer plantation. Those trees would not have been there kind of 50 years, 100 years ago. That's like that's an interference by people. This grass wouldn't be. This has been cut. The trees have been removed so we can have sheep on that field. That's not a natural situation. If that was left, trees would grow there again. But we usually just talk a bit about this because it's like there's a lot of opposition in the UK to renewable energy sometimes. So wind turbines, we have really, really strong opposition, and people get really angry about it. And there's lots of campaigns against renewable energy sometimes, and because they think it's like I don't know, affecting the landscape, or it's doing something that's unnatural or something. But actually, you could look at this landscape and think, oh, this is really natural and lovely and it's been left how it should be. But actually, like everything you can look at here has been changed by people, and it just depends on what I think it's just quite helpful to think about that it's not just there's this landscape that's pure and natural, and then we're putting a wind turbine in the middle. Like all of these things have changed because we've needed something. We've needed wood from those trees, or we've needed wool from the sheep, or whatever. And what can you hear? If you listen, what can you hear? What are the sounds?
Motorway, I think.
Yeah, motorway. Well, yeah, road. Yeah. Anything else?
Just water.
Just the water. Yeah. So there's a wind turbine, quite a really big wind turbine, like only about a kilometre that way. You can't hear that at all. But we would get a lot of opposition to that. But then the road is kind of nobody minds about the road because it's like but it's actually a lot louder. But yeah, we have to talk a lot about. I don't know. But do you have that same kind of thing on the continent? That opposition. Yeah.
People are against. I don't know. Probably they want a lot of money for the land. Maybe that's why.
Yeah. Yeah. I mean, obviously, there's situations where it doesn't make sense to put wind turbines, but it's not
It
always
seems
just
quite harmless, right?
quite a what.
Harmless for the environment. Windmills.
Yeah. So okay. Yeah. If we could move on from it. talking about, you know, energy is really difficult to make, to generate, isn't it? It's not like a quick, cheap thing to do. You know, you have to go and get oil from somewhere, or you have to work really hard at you know, installing a wind turbine and getting all this stuff done. So it's really like what these people wanted to do in the beginning. It makes a lot more sense to reduce the energy use rather than carrying on and then trying to match this growth. So there are a number of things you can do to try to do that. So when we think about energy use in your home, so you've got energy use for appliances, so things like TVs, computers, kettles, and all of that. And then you've also got energy use for heating and hot water, haven't you? So which one do you think takes the most? The appliances, electricity appliances, or the heating and the hot water?
Probably heating.
Heating?
Yeah, the heating and the hot water, yeah. So in the UK, we use, for the appliances, we use 4,000 kilowatt hours a year, usually, around 4,000 per house. But for, who wants to guess what, for the heating and hot water, how many kilowatt hours do you think a year?
Twice this amount?
4
Twice?
times.
Four times?
It's actually about 3, so yeah, 15, yeah, maybe nearly 4, yeah, 15,000 kilowatt hours for the heating and the hot water. So if you can reduce that 15,000 kilowatt hours, then you're already making gains, because you know you're saving energy, you're saving money, and it just makes more sense to reduce that rather than try and find a sustainable way to meet that amount. So there are a number of things that you can do for that. So I've just brought you in here to look at this wall, really. So this is a rammed earth wall. So it's made of a mixture of clay, gravel and sand. And then it's been very heavily compacted so that it's very, very dense. And because of that, it has a very high thermal mass. So it means that it takes in energy really, really slowly. So from the sun, takes in the sunlight really, really slowly during the day. So during the day, you don't need the heat. So it's just taking it in. And then at night, when the temperature of the room drops, this wall has to release its energy. So it releases the solar energy very slowly. And then that stops, that means that it increases. I mean, this isn't the only thing you would use. You might still need some heating. But it's just, for example, if you didn't have this wall, maybe in the room it would be, I don't know, 5 degrees or something. But then with the wall, maybe it's like 10 degrees or something like that. So I don't know what actually the numbers are, but it just increases it a bit so that your heating demand is reduced. So maybe the heating demand isn't 15,000 kilowatt hours anymore. It'll be less than that. But it's just that doesn't cost anything, and that's not, you're not having to put any input into that. And that's called a passive solar technique. Has anybody heard of that passive solar technique? We're talking about that a lot because it's basically using physics to think about how you can use energy less in your home. So you think about how the materials you think about how the materials and the air and react to sunlight, and how you can make the most of it rather than just, you know, that we have really bad buildings in the UK. We have a history of building very poorly insulated buildings that require a lot of heat, and all we're doing is heating the outside. You know, we're heating our gardens and we're heating the street. We're not heating our houses if you don't have proper insulation and proper kind of techniques to keep the heat inside. So this is another thing. So we have these skylights at the top. So this is facing south. This is south. So the sunlight. So we've got these skylights so that the sunlight will hit these walls. That's what that's for. So the sunlight and the wall together. That's a passive solar technique. It's actually the people who work in the shop. They've actually said that in the summer sometimes they overheat a bit. They've got too much heat in there. So we're actually going to put some this special type of solar panel in these. Maybe you've seen them before. Do you work with solar panels? So you do energy and
No, we didn't.
You don't. Okay. Well, we've got some different types on site. And one type is in setting glazing. So the cells are kind of, they're fibre cells, but around them there's glass, so the light can come through. So the sunlight hits the cells, but all around the cells it can come through still. So it's not dark, and it just provides some shading, but it lets light come through. So we're going to put them here. But we have some we can see later on. Yeah. Okay, cool. Shall we move on to the next, please? Maybe, yeah. I don't know.
Yeah?
Maybe. I don't know.
The wiatr tam
Yeah.
spała.
Yeah. Yeah. It's really cool. Yeah. Okay. So this building is called we call it the self build because you can build it yourself. It's a very basic style of building, so you don't need lots of machineries and like professional kind of people, like contractors and things like that. So we have it here as an example because it's very low waste. So it was designed by somebody called Walter Siegel, who was a German architect, and he didn't like the amount of waste that there was in the construction industry. So in the UK, it's something like 24% of waste is from the construction industry, and there's a very high energy cost to that. So cement, making cement is a really energy intensive process. I think it's for every ton of cement that you make, you release a ton of CO2, and that has a really massive effect on climate change and on pollution and everything. So this Walter Siegel, he wanted to make a building with a very low embodied energy. So this building, it doesn't have a lot of energy use associated with its construction. So he did that he designed it so that all the pieces were the same size as the pieces you buy from the shop. So this piece here, that's just like the standard piece from the hardware store. So you wouldn't have to cut it and you wouldn't have to do anything. So you cut down on waste and the energy use associated with the waste. And he also didn't use any wet trade, so he didn't do plastering, he didn't do bricklaying and things like that. And that means that the building's really light. So one thing that costs a lot, that has a high energy cost and just general cost is making the foundations for the building. So if the building is really heavy, you have to have really heavy, deep foundations in the ground to hold it in place. But because this is a really light building, it basically doesn't have foundations, and you can see that it's kind of on legs. It has its own legs, so it also means that you can build on uneven ground, not flat ground. So this land, we've just talked about, it was like this, and it's just that this is just a pile of rocks. This is really difficult to dig into this. It's just like sort of rocks. So this meant that they didn't have to hire a lot of machinery and have a lot of energy going to use that, and it's just quite a cool system. We have a conservatory on the front, so that's another passive solar technique, like we were talking about with the wall and the large windows facing south. So this is also facing south, and the idea is that during the day, the air in the conservatory heats up, and then at night you open the door to your house and the warm air comes into your house, and it's just another way to just get kind of free heat. So it's one thing that you can do. Yeah, it's another style. Yeah.
But in winter time it is really cold as well, right? So
but it also provides like a buffer, provides like a barrier. So it's like that air is going to be slightly warmer than the air outside. So it makes it more difficult for the heat inside your house to get out. Yeah, when you open that door, you never have both doors open at the same time. You just have that door and then close it, and then open that door. But we have students staying here sometimes. So over here we have. So this is an air source heat pump. Have you come across heat pumps before?
Yes.
Yeah. Do you work with
Heating pump.
heat pump? Yeah.
I heard about it. Sometimes I read about it. Yeah.
Oh, okay.
Yes.
Have you studied it on your course or the course you're
No,
doing?
we will.
You will. Yeah. Okay.
Do.
So this is it has two parts of it. So this is the unit outside, and then that kind of the thing that looks like a refrigerator. It's not a refrigerator. That's the inside part of it. We've got a diagram on here. So it kind of works. So it takes there's a gas inside. In this case, it's CO2. It's a kind of a different type. Usually, it's some other types of gas, but this is a special type of CO2. And the CO2 is allowed to. It absorbs the heat from the air, and then it's compressed until the temperature is useful to us. We take it out and store the heat on a hot water tank, and that can be used for for domestic heating in the house. So and then the gas is then allowed to expand, and it carries on its cycle. So there's quite a good diagram of that here, like that. So you can get air source heat pumps, ground source heat pumps, and water source. I'm sorry, I keep talking. I'll just put it in my pocket. You can get air, water, and ground source heat pumps. So the air source heat pumps, they have a more variable kind of usefulness because obviously the air temperature changes a lot. You know, here sometimes we have -16 or something. I don't know. Do you have it? What's the lowest temperature you have?
In Poland, minus
30.
30
30.
happens sometimes.
Okay. Well, we think the -16 is just like so extreme and really like yeah.
It's
So
a quite
Disaster,
standard
right?
in Poland.
is it really? Alright.
In the winter time, of course.
Yeah.
Okay.
When
No, it
when
happens.
yeah.
Sometimes happens.
-30. Well, when people from the UK come from England, they're really shocked by the -16. They just can't believe it. So it's just yeah. So you know the temperature changes so
Wales
much.
is warmer than.
Well, we just have so much rain because we have the mountains.
Yeah,
We have a
because of the
mountain
mountains,
range.
Maybe
Yeah,
the
yeah,
average temperature is
yeah,
lower.
yeah. It's just very very wet. But yeah, the north of England is also very cold. But yeah. But so the ground source heat pumps, which we don't have because it's too difficult to drill into the ground because of all the stone, they're usually a better performer throughout the year because under the ground you have a more standard temperature throughout the year, like at some, so that's less variable. And we do have a water source heat pump as well down at the bottom station where you normally come into when you take the railway, the train. But yeah, again, that's quite a variable temperature. Yeah, but we have done I mean, these are supposed to be used with low temperature heating. So, for example, if you use gas or wood or oil or something that you can just burn on demand and burn a lot of it, you could use the radiator systems. So that's what normal houses in the UK have, is radiator systems. So we use the gas or the oil or the wood to heat the water, which is then passed around the house in the radiator system. But for that to work, you need kind of quite high temperatures, so like 50, 60 degrees. But then with these systems, so the air source heat pumps, this is more efficient if you provide low temperature, so like 30 degrees, 20 or 30 degrees. And so if you're going to only provide the house with 20 or 30 degrees, you need very, very large surfaces to let the heat be released from. So that's why these should really only be used with underfloor heating. Is that common in Poland to have underfloor heating? Or?
No.
No, it's not common.
Underfloor, yes.
Yeah,
It is, but yeah, of different way than this one.
Yeah,
But it is
We think,
something
yeah,
like
yeah. With the
gas
gas
Yeah.
or oil, yeah.
yeah.
and the tubes go
Oh, okay.
with water go under.
Yeah, yeah.
You are
Okay.
thinking about this?
Yeah, under the floor. Yeah,
Yeah.
yeah. But then the temperature, yeah, it doesn't need to.
In
Yeah,
your houses it is proper.
yeah.
But only in not all rooms you can put. Like bedroom is not.
It's
Yeah.
not healthy, yeah, so I think that
Yeah.
most
Nobody puts
Yeah.
in bedroom.
living
or
rooms, kitchen, yeah.
living room,
Oh, okay.
corridors.
I think some people are worried that if
bathrooms.
you fall on it or something. I mean, apparently you can burn yourself if you like for elderly people. Apparently, if you fall and you're not very sensitive, you stay there.
It's not
No,
so
it's
hard
not.
to be
But apparently,
bored, no.
but over kind of 10 hours or something.
20
I don't know.
something
Yeah.
degrees.
Yeah. No, but apparently it is possible for people who are quite like elderly people. Or
Yeah?
something. Yeah.
From this.
Well, for the underfloor
What is
heating in general.
the
yeah.
highest temperature of air you can get from this?
Well, usually the maximum is supposed to be 30 degrees. You're supposed
30
to, yeah,
degrees.
you're supposed to do. That's yeah,
But it's
and
enough to heat
yeah,
the house.
yeah. If you're using the right type
30.
of heating system, yeah, yeah. Okay, okay. So we'll move on. You can see the width of it. This is the width of one. Can you imagine a straw bale? So it's kind of that big. So this is the width. The whole building is built just to the size of the straw bales. So rather than talking in like meters or millimeters or something, they use the actual the dimensions of the straw bales to build it. So this building, it was built in the year 2000 by volunteers. So again, it uses kind of low low impact, low embodied energy, local materials. So it's local wood, local straw, and the straw otherwise would be possibly a waste product. So it's not kind of importing lots of materials from abroad or using materials that have very high energy costs. It's using local things that might have otherwise been waste. And straw is a very good insulator as well, so it helps to reduce the energy use of the building in the first place. It's just quite a cool building. But with all of these, so then we have this render on the outside which needs to be able to breathe, so that the water can be absorbed and be released again. But you have to do certain things with this. So you have to have this overhang of the roof. The roof has to come out a bit, because you can see on this one they had some extra straw and they made this extra little wall, and you can see that looks terrible. That's starting to kind of rot because they didn't have the overhang there. So the natural materials they do work, but they need to be used in a proper way. Like they need to be protected from the weather and things like that. Yeah. Do you build with straw much? Or
Many years ago.
Oh, okay. Oh, like thatch. Oh, okay. Yeah. Yeah, we have that sometimes. Okay. So we're going to go into this building now.
Jemy lunch? Wasze kanapki jemy. No. Parę chwil chyba. Na pewno jak skończymy tutaj. No nie wiem, Paweł. Na piątą mamy być z powrotem.
Jak?
Na piątą mamy być z powrotem. Nie wiem w ogóle, jak na
So, has anybody heard of a passive house? Passive house.
Domy pasywne. I think they heard about it.
Yeah.
I don't know much.
Okay, so it's a German concept that I just think is really, really cool. I'd really like to live in a passive house. I don't. I just live in a normal house, which is kind of cold. But I'd really love to live in a passive house. And this building, we call this the whole home. This was built before the passive house idea came about, but it's kind of built in the same sort of way. So we're using passive solar techniques. So we have the conservatory again, thinking about things that you can burn to generate heat. So we have several types of boiler here. So several types of technology that we use to generate heat from biomass. Is it quite common to burn wood for heat in Poland, or more gas?
Something normal, yeah.
Oh, is it really? Okay. Oh, okay. It's still quite like these are quite new and fancy here. Everyone has gas usually. Most people are on gas, so this is kind of alternative here. For heating systems, like gas is the most common in the UK. Yeah. Yeah. But in this kind of way with boilers, or kind of just in the fireplace, or like in the fireplace. Okay. Yeah. So we use these can heat hot water and provide heating, space heating as well. They do both things. So this is the one we use every day. So we own some woodland here. So there isn't any glue in it, so it's not releasing some toxins into the air when you burn.
Under pressure, yeah?
Under pressure, yeah. The cells. This is a really good fuel because it's very, very dry, it's got a good. It's small, so it's got a good surface to volume ratio. So it's very easy to burn it. It's also quite easy to transport. You can buy it in bags, but it's kind of a bit more expensive, and the process of putting it into bags has an energy cost to it. Something like 10%, 5 to 10% of the energy from the bag has gone into making the bag, basically the plastic and the processing. Or you can have a big trolley, a big truck that comes and just plugs a pipe into that one and fills that up. That's what we want to do, but it's really hard to get access here. So we're going to put this outside, out the back, and then we're going to have a van like drive up the back road and then walk to the trees with the pipe. But yeah, so I'm going to put this in. So can I have a volunteer? Could you hold this? So if you put this in here, do you think it's going to float or sink?
Float.
Who votes? Who says float? Who says? How many people say float? Float. Who says sink? Sink. Who says sink? Okay, let's see.
One person.
Let's see. What's going to happen?
Oh.
Jesus Christ! It's so dense. So it's just to show how compacted it is. It's very, very dense. The cell walls are broken down and molded together. That's how dense it is. And it's just a good fuel. It's there's a lot of energy in this. So this is the one that we use, this pellet boiler. And this is the same but demonstration version. So we have an auger in here that takes pellets from this hopper. So the pellets are fed from this system here onto this plate, and it's just a few at a time. It's just like a handful at a time, just a few, and they burn just slowly, just constantly feeding heat into that system. Then this passes heat to this. So water is normally in this part, and so the heat is passed from here into the water jacket. This is very well insulated, so the heat can't leave.
Yeah.
And then the heat is taken off this and fed into the tank again. So it's like several different water systems. Water's a really good way to store and transport energy because it has such a high specific heat capacity. And these things. So when these are burned, the gases, so the smoke and the gases that release, it's passed around here. So there's heat being passed from the exhaust into the hot water, and then these things are here just to stop it getting clogged up. So every now and again they just jump. They're just programmed to just jump, and then they shake off all the stuff. And then every month or 2 months or something, you just come and you open this, and then you take out a tray with the ash, and then you just put it on your garden or in your compost heap or something. So it's quite very low maintenance. This one very, but it's still quite expensive in the UK to do this. We have lots of financial subsidies to try and support people investing in these kinds of technologies. So we have something called the Renewable Heat Incentive, and that the government basically pay you to generate heat from a renewable source. So if you have solar thermal panels that generate that provide you with hot water, or if you have a biomass system, the government pay you an amount of money per kilowatt hour that you generate. And then so after 7 years, it's supposed to be about 7 years, maybe it's less than actually, you can pay off the cost of the system. So the system can be kind of free, but you have to wait because you receive this money every year depending on how much you generate. So we don't have like a grant for you to buy it in the first place, but it takes some years. And we have one system for domestic users, so for homeowners, and then another one for companies. So companies can buy quite large scale renewable heat systems and then pay it off quite quickly. But yeah, do you have something like that? Do you know if you have some subsidies or?
Yes, in Polish houses becoming more and more popular for pellet heating.
Yeah. Do you have support from the government to
No.
buy it? No, it's
No.
just used by it. Yeah.
Polish government supports miners.
Right.
Not
What, for coal or
for coal,
For coal. Okay. Yeah.
because it's a friend
Yeah.
of mine.
We burn pellet in traditional boilers,
Okay.
as well as wood and carbon.
Right. Okay. What? Just kind of this? In the fireplace in the house,
No fireplace, like a boiler.
like a boiler.
Yes,
Okay. Yeah.
a lot of supplies can be burned in such.
Oh, so it's like multiple fuel.
Yes,
yeah,
yes.
Yeah.
Yes,
Oh, okay.
nice
Well, that's
sound,
interesting. Yeah. Is it some? Because this is supposed to be multiple fuel, but we don't use it. Is it something like that? We don't really use it. It has
Yeah, I
one
think
share,
it was one, yeah.
pellets, logs, and you just switch something and it burns differently. But we did it doesn't work yet.
What is the expensive? Pellet or the device?
Sorry, what's more expensive? Sometimes this ends up being free eventually after 7 years it pays off. But the pellets are actually, it can be, if you buy it in bulk from the truck that comes, it can be cheaper than gas. So in the UK, gas is about 4 pence per kilowatt hour, and this can be something like 3.5 pence if you buy it in bulk. If you, yeah. But so and with the subsidies as well, yeah. But it's a matter of, do we have enough biomass for everybody? We don't have enough biomass for everybody to do this in the UK. Like it just doesn't. We have 12% forest
Enough
cover.
food, yeah?
Yeah.
Wood.
It's possible if we use all the waste wood. We use all the waste wood that normally would be thrown away, and then we manage.
Pellets might be done not only from it, from other waste, yeah?
I don't know. Do you use it? Do you make pellets from other products?
I've heard that some other, I don't remember now what.
Okay. No, I haven't heard of that. Okay. Yeah.
Zostajemy tu?
Down on home to use electric light because, but it also stops this area overheating in the summer. But I just think it looks quite cool and quite a nice effect. Yeah. So in here, so last year we celebrated our 40th anniversary, and there's just some quite cool pictures in here of kind of early renewable energy technologies and things. So I thought we'd have a look in here. Yeah. So. Yeah, if you just want to take 5 minutes just to have a look around, there's some interesting things about kind of early solar panels, early wind turbines.
Your favour?
Yeah.
I mean, Bob, of course, was a key part of it because he was stringing electric cables across trees all around the site. It was like a spider, which of course didn't have any regard at all to regulations or anything else. We have to have obviously
So again, we have the really high thermal mass walls. They take in the heat very slowly and then release the heat when you need it. And you have these really tall south-facing windows all along this wall so that we can make the most of the solar energy. So that just it gives the room, the base temperature of the room is higher than if you just... It's a really nice atmosphere to be in to study. So we have, and then this side is the base of the ground here is kind of the slate and more kind of rock base. So it kind of gives a quick recharge to the reservoir. So when the water falls on it, it drains really quickly. It's very permeable, the ground. And on the other side, it's more kind of clayey, so it holds onto the water for longer, and that kind of gives a slow recharge rate. So we've got this balance of recharges, which is really helpful. And usually I just come round onto here and just look at count how many steps there are on the ladder there, and that takes holding. Yeah. So, can anybody? So what we're talking about when we're doing the workshop for hydroelectric power, we care a lot about the energy that's stored in the water, because that's what's we're going to use to generate the electricity. So, does anybody remember from like high school or something the equation for potential energy? Stored potential energy. So potential energy is the energy stored in something that's at a height. So we care about how high up it is, how much of it there is, and the effect of gravity. So it's the mass times the height times well it's sorry, what is it? Yeah, exactly, mgh. So the h in this case is the height of this water.
Gravity and mass.
Yeah, so the mass of that's great. So the height is from the surface of the reservoir, or like from the in to the turbine that we're going to be looking at, and that's what you're going to be measuring in the pool. So that height, so that's the height that the water has to fall while it's being acted on by gravity, and that's what gives us the energy that we use to generate the electricity. Should we show the quarry or not? So this is the quarry. So they took slate out of this for 200 years using dynamite, and this is how it hasn't been used since 1951, so like 65 years or something. So that's how the trees are just growing back. It kind of just looks like, I think it looks like some kind of Jurassic Park like kind of thing. It's really beautiful. But yeah, so they used to so slate from this quarry has just gone. It's on roofs like all over the world. It's quite, because Welsh slate is quite famous for that kind of stuff. Yeah. So all of this slate, the waste part of it, is what's making up the hill that Cat is on. Like I was saying in the beginning, that's what that is. Okay. Has everyone taken pictures that wants to? Yeah.